Question number 1. A person standing on the bank of a river observes that the angle of elevation of the top of a tree on the opposite bank of the river is 60 degrees, and when he retires 40 meters away from the bank opposite to the tree, the angle of elevation becomes 30 degrees. The breadth of the river is, first option 20 meters, second option 30 meters, third option 40 meters, and fourth option 60 meters. Look, let us say this is the river, this is the bank 1 and bank 2. A person is standing here, and there's a tree out here on the other bank. Now when he moves 40 meters away from here, the angle of elevation will be reduced. It was 60 here and 30 here. So let's put it this way. Let us say this is the top of the tree on the other bank. This is the bank here. This angle of elevation is 60 degrees. When the person moves 40 meters away, the angle of elevation will have to be reduced. So that is 30 degrees now. Now what we want is the breadth of the river. This is the breadth of the river. Okay. B. Let's find out what is that B here. Let's say H here, height of the tree. This is the tree here. Okay. H by 40 plus B is equal to tan 30. Opposite by B plus 40, that is equal to tan 30. That's 1 by root 3. Similarly, one more equation we have here. H upon B is tan 60. That's root 3. Call this equation 1, call this equation 2. Let's divide one by the other. 2 divided by 1 will eliminate H and will give us an equation in B. What do we have here? 40 plus B by B is what I'm going to get when I divide 2 by 1. And on the right hand side we'll get 3. So 3B plus 3B minus B is equal to 40. That gives me 2B is equal to 40. So this implies B is equal to 20 meters. So the breadth is 20 meters, and that's clearly appearing in the option 1. Option 1 is the right answer. Okay, let's move to the next question. A tower stands at the center of a circular park. A and B are 2 points on the boundary of the park such that AB is equal to A, small a. It subtends an angle 60 degrees at the foot of the tower, comma, and the angle of the elevation of the top of the tower from A or B is 30 degrees. Then the height of the tower is, first option 2A by root 3, second option 2A root 3, third option A by root 3, fourth option A root 3. Now we have a circular park. Let us say AB is a chord of length A. This length is A. Now he says that this AB chord is subtending an angle 60 degrees at the center, and here we have a tower situated here at the center. So there's a tower here. So let me put it like this. There's a tower here. Okay, this we want to find the height of this tower. Observe that he says that the angle of elevation from A to the top of the tower. Let's call this as some T, top of the tower, is 30 degrees. This is 30 degrees. Now OA is equal to OB, and this is isosceles triangle. AB side is length A, isosceles, and the angle included between the equal sides is 60. Therefore, the triangle OAB is clearly equilateral. Okay. So OA length is equal to OB, and that angle included between them is 60. So it has to be an equilateral triangle. Therefore, we can say that OA is equal to OB is equal to AB, and that what is AB given to be? A. So this is small a. And now we have situation like this. OT, this is the tower, this is a tower, okay, and this is your A. This angle is 30. Okay, this length is A. We want to find out H. H by A is clearly tan 30. So H has to be A tan 30, that is A by root 3. So height of the tower, which is situated at the center of the park, will have to be A by root 3. So A by root 3 meters, and the right option is option 3. Option 3 is the right answer. Let's move to the next question, question number 3. AB is a vertical pole with B at the ground level and A at the top. A man finds that the angle of elevation of the top, that is A, from the certain point C on the ground is 60 degrees. He moves away from the pole along the line BC to a point D such that CD is equal to 7 meters. From D, the angle of elevation of the top of the vertical pole is, that is A, is 45 degrees. Then the height of the pole is, first option, 7 root 3 by 2 into 1 by root 3 minus 1. Second option, 7 root 3 by 2 into root 3 plus 1. Third option, 7 root 3 by 2 into root 3 minus 1 meters. Fourth option, 7 root 3 by 2 into 1 upon root 3 plus 1 meters. We have a vertical pole AB, B at the ground, that's what is given. A is the top, this is the pole. Let's say the height of the pole is H. C, at a point C on the ground, along the ground, if you look at the angle of elevation, that was 60 degrees. That is 60 degrees here. And now, when it is moved, when the person walks away from the pole by 7 meters from C, this is 7 meters, he finds that the angle of elevation is reduced, and that is 45 degrees here. Now what we want is the height of the pole. Look here, H by BD is tan 45. So BD will be equal to H. So this will be entire length BD is equal to H. So this entire length is H. This will be H minus 7, because the total is H and this is 7 meters. So let's write it as H minus 7. Okay, now what else you know? H by H minus 7 is again opposite by adjacent, that is equal to tan 60. Tan 60, that is equal to root 3. So H is equal to root 3 into H minus 7. So let's now have it like this, 7 root 3 is equal to h into root 3 minus 1. H into root 3 minus 1. Therefore, we have, what is h? 7 root 3 divided by root 3 minus 1. Now, that can be rewritten as this way. We will multiply and divide by root 3 plus 1. We will multiply and divide by root 3 plus 1. That is, we are rationalizing the denominator. So, what do we get here? We then get 7 root 3 into root 3 plus 1 in the numerator, and in the denominator root 3, it becomes 3 minus 1, that is 2. That is equal to your h. So, right option is, option 2 is the right answer. Option 2 is the right answer. Let's move to the next question. Question number 4. The upper 3/4 portion of a vertical pole subtends an angle tan inverse of 3 by 5 at a point in the horizontal plane through the foot and at a distance of 40 meters from the foot. The possible height of the vertical pole is, first option 20 meters, second option 40 meters, third option 61 meters, and fourth option 80 meters. Now, we have a vertical pole. This is the ground level, let us say. Vertical pole, let's call this as AB. B is at the ground level. Now, 3/4 of this, let us say the entire thing is h. So, 3/4 of it, that is 3 by 4 h. This portion at a point 40 meters away from B, this portion is subtending an angle this is C, let us say. This is 40 meters away from it. This is subtending an angle tan inverse of 3 by 5. This is theta, where tan theta is equal to tan inverse of 3 by 5. Now, if this is 3/4 of h, this will be h by 4. Let us think that this angle is some alpha. Okay, here. So, tan theta is equal to 3 by 5. Okay. The total angle is theta plus alpha. What is tan of theta plus alpha? Let us consider that. What is tan of theta plus alpha? The tan of this angle. That is opposite side by adjacent side. That is going to be h by 40. So, that is again tan theta plus tan alpha by 1 plus tan theta tan alpha. 1 minus tan theta tan alpha. And that is equal to h by 40. But what is tan theta for us? Tan theta is 3 by 5. So, 3 plus 5 tan alpha divided by 1 minus 3 by 5 tan alpha. So, that makes it 5 minus 3 tan alpha is equal to h by 40. Call this equation 1 there. Call this is equation 1. What I have done was I have substituted tan theta equal to 3 by 5 and took the LCM and then simplified. So, that came out to be 3 plus 5 tan alpha by 5 minus 3 tan alpha, and that is equal to h by 40. What else we can use? This again, h by 4 by 40, h by 4 by 40 is equal to your tan alpha. H by 4 by 40 is equal to tan alpha here. Okay. So, here let us see what we can do here. So, what we have here is h by 160 is equal to tan alpha. So, we can substitute tan alpha to be h by 160 here and get the value of h. So, what do we have? 3 plus 5 into tan alpha, that is h by 160, by 5 minus 3 into h by 160 is equal to your h by 40. Okay. So that makes it here 3 into 60, 480 plus 5h divided by 5 into 160, 800 minus 3h is equal to h by 40. H by 40 here. Okay, we can actually substitute and see also from the options now. Instead of going about solving for h, we can substitute from the options and see. Now what is it? If I put the first option 480 plus 100, 580 divided by 800 minus 60, that will not be equal to your 20 by 40. So that won't be the option here. So if I take h to be 40, if h is 40 now, what happens here? 480 by 200 divided by 800 minus 80, that comes out to be 680 by 340 is 120 here, that divided by 680. So that matches. That will be 1. When h is 40, I am going to get the right hand side also to be 1. So clearly from the options we can go and then find that h has to be 40. So h is 40 meters. We went for back substitution at this stage. That saves some time here. So option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question. Question number 5. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground and making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Let's say this is the point where this was the tree here. It has been broken and now the top of it looks here. So this is the height of the tree originally. After the storm, it has been broken here at this point and this portion has come down. Okay. Let us say this length here, he has given it to be 8 meters. And it is, he says this angle is 30 degrees. Okay. Now let us call this as x and let's say call this as y. It was this y which would have contributed to the total height. X plus y is the total height. X plus y is the total height of the tree before it was broken. So it was broken at this point at a distance of x from the ground, let us say. That x, I mean that got folded and then it is y now. So x plus y is equal to your total height h. So I need just to find out x and y. Here x by 8 is equal to opposite by adjacent here and that makes it tan 30, that is 1 by root 3, tan 30. And what else? Your 8 by y is equal to adjacent by hypotenuse and that will be cos 30. Cos 30 is root 3 by 2. So what we want is x plus y. What is x? 8 by root 3. And what about y? 16 by root 3. Y is 8 into 2 by root 3. That makes it 16 by root 3. Your x plus y is therefore 24 by root 3. That I can write it in the form of 8. That is 8 into 3 into root 3 by root 3. So 1 root 3 cancels and you have 8 root 3. So we have here 8 root 3. So clearly option 2 is the right answer. This is our height of the tree. So option 2 is the right answer. Question number 6. A kite is flying at a height of 60 meters from above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string assuming that there is no slack in the string. First option 40 root 3, second option 40 root 5, third option 20 root 5 and fourth option 20 root 3. Actually this problem has only to do with understanding of English. So once you understand that, it will just come in no time. What is it? We have a kite flying at a height of 60 meters from the ground. The string here has no slack, in the sense it's tight, and it is tied to a point on the ground. Let us say, let's call this as point B and this is A, and the point C here. Height of the kite, B is AC. Now what we are asked to find the length of the string, L, and this angle is 60 degrees. So clearly what do we have here? This is 60 by L is equal to sine 60. So L will be 60 by sine 60, that is, and that is equal to, L is equal to 60 by root 3 by 2. So that I can write it into 2. Okay, that makes it 20 root 3. 60 by root 3 is 20 root 3 into 2. So that makes it 40 root 3. So L is 40 root 3. So length of the string is 40 root 3. It says there is no slack, means it will be tight. So it is tied to a point on the ground. This is the point B where that string has been tied. Length of the string, let's call it as L. This is the height above the ground where the kite is flying. So 60 by L will give us sine 60, and that from there I got it. So the option 1 is the right answer. Option 1 is the right answer. Question number 7. Let's move on to the next question. Question number 7. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building. First option 19 root 3, second option 18 root 3, third option 19 root 6 and fourth option is 19 root 2. Okay. Let's say this is the building. Person AB is the building, which is of 30 meter tall. This is 30 meter tall. A person is initially at some point C, standing at C. His position is, this is the person here. His height is 1.5 meters. Okay. Now he moves through a distance, some distance he moves through a distance. Right now his angle of elevation to the top of the building, that is from here, if you measure the angle of elevation, that is 30 degrees. After some distance, let us say he has walked through up to this point E. Okay. So now this is the G here. Let's call this as F. Okay. He has moved from C to G. And now the angle of elevation has increased to 60 degrees. Okay. Now what we are asked to is find out is what is the length CG. Let's call this as X. Okay. Let's call that as X. So what is the length? CG there. Now observe that this is your AF is 30 minus 1.5. That let's convert it into fractions. 30 minus 3 by 2, that is 57 by 2. 57 by 2. So this is 57 by 2, AF is 57 by 2. Now, what about FD? AF by FD is equal to tan 30. So in other words, FD will be AF by tan 30. Or that is 57 by 2 divided by 1 by root 3. So 57 into root 3 by 2. That is FD. When it comes to finding out, what we want is CG, and that is nothing but ED. Let's find out FE. Again, AF by FE is equal to tan 60. That's root 3. What is AF? 57 by 2. So 57 by 2 by FE is your root 3. That's root 3. So what is FE? 57 by 2 root 3 is our FE. Okay. Now what we want is DE, which is equal to CG, the distance through which he has walked. That is clearly FD minus FE. What did you find FD to be? 57 root 3 by 2. So that is 57 root 3 by 2 minus, what is FE? 57 by 2 root 3. By 2 root 3. We will take out that 57 by 2 common, and we have here root 3 minus 1 by root 3. That makes it, what does it make it here? 57 into 2 by root 3, because 3 minus 1 by, and that divided by 2, that makes it 57 by root 3, which is nothing but 19 root 3. So 19 root 3 is the right answer. So option 1 is the right answer. Okay, let's move to the next question. Question number 8. The angle of elevation of a top of a building from the foot to the tower is 30 degrees, and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 50 meters high, find the height of the building. We have a tower here. This is a tower. All right. And we have a building here. So this is the building. And this is the tower. Let's say AB is the tower, and CD is the building there. He says this angle is 30 degrees. The angle of elevation of the building, top of the building from the foot of the tower is 30 degrees. And yes, the reverse is this angle is 60 degrees. And the building height is known to be, height of the tower is known to be 50 meters. We got to find out the height of the building. H is what we want. So, what is common to both these triangles? BC is common. So, we will eliminate that. We will write BC in two ways here. What is that? 50 by BC. In this triangle ABC, 50 meters divided by BC will be tan 60. That is tan 60. That's root 3. Again, let's call this as H. That is DC by BC. DC by BC will be again opposite by adjacent in this triangle BDC, and that will be H by BC, and that is again tan 30. 1 by root 3. So, let us divide one by the other. What do we have? 50 by H. Dividing 1 by, call this as 1, call this as 2. 1 divided by 2. 1 divided by 2. What does that give us? This BC will cancel and we will have 50 by H to be equal to 3. H is therefore 50 by 3. H is equal to 50 by 3, that we can write it in the form of 16 2 by 3 meters. 16 3 is a 48 plus 2 50, 16 3 by 2 by 3 meters. And that is clearly appearing in the option 1. Option 1 is the right answer. Two poles of equal heights are standing opposite to each other on either side of the road, which is 80 meters wide. From a point between them on the road, the angles of elevation of the top of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles. So, we have a road here. On either side of the road is the road. On either side of the road we have two poles of the same height erected. Two poles of same height are erected. This is the road, and some point, at some point C on the road, this BD is the road, some point C on the road. If you measure the angles of elevation for top of one of the pole, this is 60 degrees. And for the other is 30 degrees. For the other is 30 degrees. So, what we are asked to find out is this height H. Now, the breadth of this road is 80 meters. 80 meters is the breadth of the road. This is the road. Okay, this is our width of the road is 80 meters. Let us call this length to be x. This will be 80 minus x. So, what we can do is we will frame equations in h and x. H by, this is also h, h by x is tan 60, that is root 3. H by x is tan 60, that is root 3, and h by 80 minus x is tan 30, that is equal to 1 by root 3. Let us divide one by the other. What do we get? 80 minus x divided by x, dividing one by the other, 1, 2. 2 divided by 1 will give us 80 minus x by x is equal to 3. So that gives me 3x plus x is equal to 80. That gives me x to be 20. So x is 20 meters. So this length is 20 meters. So clearly h will be x root 3 from the first equation, that is 20 root 3. H is 20 root 3 meters. So here we have 80 to be 3x plus x. So x is equal to 20 meters. Therefore, your h is x root 3, that is 20 root 3 meters, and that is clearly appearing in the option 4. Option 4 is the right answer. Question number 10. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees and the angle of depression of its foot is 45 degrees. Determine the height of the tower. First option 19.124 meters, second option 191.24 meters, third option 1.9124 meters, fourth option none of these. Let's have a look. Let us say AB is a building, and let us say CD is a cable tower. This is let's call this as CD and E, somewhere here, E. So C is the cable tower. This is the building. We have a building here. The height of the building is 7 meters. This height is 7 meters. Let's draw a line parallel to the ground here from A. He says that the angle of elevation of the top of the cable tower is 60 degrees. This is 60 degrees from here. Measured from the top of the building. So angle of elevation of the top of the tower measured from the top of the building. This is the building here. That is 60 degrees. And angle of depression, that is, this is 45 degrees to the bottom of the tower. Bottom of the tower is this. This is the bottom. This is the top of the tower. This is the angle of depression from A. This is 45, therefore this also should be 45. And if this is 7 meters, clearly BC also has to be for 7 meters. This is 45, this is 90, it should be also 45. So this should be again 7 meters. This is an observation that we make. So AB by BC is tan 45, that is equal to 1. So AB is equal to BC there. So BC is 7 meters here. And this is also 7 meters, it's kind of forming a square here. ABCD is forming a square here. So we have 7 meters here. Let us call this length to be some x. 7 plus x is the total height of the tower. So I need to find out x. Clearly, x by 7, this is 7. X by 7 is equal to tan 60. So what is x? 7 tan 60, that is 7 root 3. Therefore, the height of the cable tower, height of the tower is this your CE, that is CD plus DE. CD is 7 meters and this is 7 root 3. For 7 into root 3 plus 1 meters. And that is approximately 19.124. So that is 19.124 approximately, meters approximately. So nearly 19.124 meters. Therefore, the option 1 is the right answer.